everybody. Thank you for watching again. This is video number 2 on solving systems of equations involving word problems. I'm going to read the word problem for you just to make sure that we can see it on the video. I'm not sure how well it's showing up. My videographer isn't here today, so I have it propped up on the desk, so hopefully you can see everything just fine. This example is about Wally's World Famous Pizzas. It's an upstart pizza company. So a Willie Nelson concert's coming to town, and Wally's company is being offered a contract to sell pizzas at the concert. The promoters want him to sell his pizzas for $25 each. It has to be $25 each. His expenses will be $1,500. He has to pay employees. He has to bring his ovens down. He has to pay for a generator for the ovens. He has a lot of stuff to pay for to make this run. He also has to pay $4 per pizza sold, so that's paying for dough and pepperoni and sausage and all that stuff. So it says find the break-even point to help Wally decide whether taking his business to the concert is a good idea. So in business, we have to make a decision, right? Are we going to break even? Can we make profit? And this is what our job to do. So this is a business type problem. I like it for that. Anyway, our step number 1 is to assign our variables. Here we're talking about selling pizzas, right? So it sounds very natural to say let x equal the number of pizzas sold. Hopefully you can sense that if he doesn't sell enough pizzas, he's going to lose money. If he sells hundreds of pizzas, he'll probably make money. But the question is, how many pizzas must he sell to break even? And that's what our job is. Okay, so number 2, it says develop the system. So this is where we're actually coming up with our equations. So there's 2 things that we're considering. We're considering Wally's income. So I'm going to call that I of x. We're used to writing y equals, and I'll get there in a moment, but when we're talking about his income is only generated by the sale of pizzas, right? So if x is the number of pizzas he sold, and he's selling them for $25 each, doesn't that make his income simply 25x? That's the only way he generates income. Okay, now we have to compare that to his expenses. So I'm going to call his expense function E of x. That way I can keep track of which is which. Okay, he has an initial expense of $1,500. That happens only once. So that's actually our y-intercept. I'm going to put plus 1,500 at the end. Right? That's the starting expense. And now how much does it cost for every single pizza that's sold? We're already told that, it's $4. So the income function is E of x equals 4x plus 1,500. Okay. Our top line has a slope of 25. Our bottom line has a slope of 4. So these 2 lines definitely have to cross each other, yes? Okay, so I'm just going to do a really rough sketch, and then we're going to do the algebra to solve it. Let's do the expenses first. It's starting up high at 1,500. So I'm going to go up here, 1,500. This doesn't need to be precise, but it's not going up too fast. So I have a line just eking its way upwards. His initial expense is huge, but each individual pizza doesn't raise his expense that much. So anyway, this equation is our expenses equation. So I'll put EXP there so we can keep straight. That's the expenses. All right, now income. Oh, look at how much steeper the slope is, right? It's going up 25 and over 1. This is going up 4 and over 1. But the y-intercept here is 0. So in other words, if he sells no pizzas, he's not going to have any income. So I know this must go through 0, 0. But since the slope is 25, it has to be much steeper. So I'm just going to approximate like so. If I had graph paper, this would be more accurate, but honestly, the algebra here is what we're trying to get good at. So I think that this is fine. I'm going to label this income. So hopefully we can see that from this x value to this x value, income is less than expenses. Is that good for business? If your income is less than expenses, doesn't that mean we're losing money? So it's this intersection point that we really, really want to hone in on. That's what will allow us to answer this question just the way we're supposed to. All right, so let's get to step 3, which is solving the system. I'm going to go to the right, and I'm going to rewrite each of these as y equals 25x instead of I of x equals. I'm switching to the y equals form. It's easier to see the substitution. And now the next one is clearly y equals 4x plus 1500. This is definitely a system where substitution is good, huh? Because notice y is by itself. And y is equal to 25x. And so if I just replace 25x in for y in equation 2, I get 25x equals 4x plus 1500. Look, we're almost to our first coordinate, our x value, right? To solve this for x, let's subtract 4x from both sides. That gives us 21x equals 1500. And we definitely want our calculator for this. I'm going to divide both sides by 21. And I don't want to grab my calculator. I wrote this number down earlier. If I take 1500 and divide by 21, this gives me 71.4. 71.4 is our magic x value. X is the number of pizzas sold. Now, it doesn't say we can sell pizza by the slice, does it? I had a student last year that said, oh, maybe they sold 71 pizzas and then a couple of slices more, and this problem we would need more information to talk that way. So we actually can't sell 71.4 pizzas. We could sell 71 pizzas, we could sell 72 pizzas. And if we only sold 71 pizzas, that puts us just before this dot. Just before the dot is where income is a little bit less than expenses, so we would lose just a few pennies on a business standpoint. But if we sold 72 pizzas now, the blue line is higher than the red line, and so income is greater than expenses, and now we realize our first tiny bit of profit. So Wally would profit if he sells 72 or more pizzas. Do you see that? This is what we want to answer. When we're done, if this is an SAT test, we would like to write a mini paragraph. Notice line 4 says, answer the question using words, observe context in the problem. So it would be inappropriate to answer here as an ordered pair. When we have word problems, we like to finish with a nice paragraph. And I would actually, if I was writing this up, I would say, Wally needs to make a decision. Can he sell 72 or more pizzas? If he feels he can sell 72 or more pizzas, he should definitely take this contract. Isn't that right? So in part, I think that would have to do with how many people can we expect at a Willie Nelson concert? You guys are young, maybe you don't know who Willie Nelson is, but he is a country singer that thousands of people will show up to watch. And so my guess is this concert will have at least 4,000 people there, maybe 10,000 depending on the arena. So think about it, a concert, all this activity going on. Do you think if he's selling this awesome pizza that he can sell 72 pizzas or more? I would say yes. Okay, so fill in a good paragraph. If Wally sells 72 or more pizzas, he should definitely decide to take the contract. If he doesn't feel he can sell at least 72 pizzas, he probably shouldn't take the contract. Okay, so this is a really good example of substitution, and hopefully now that you have one where we're using linear combinations and one that we have substitution, that the word problems on your homework will be that much better. Okay?